Okay, so I'm going to give you a quick tutorial on how to read a geologic map. And so the example that's given in the lab is this Paulden geologic map here. So when you download that PDF and open it, it'll look something like this. And this is kind of the big picture overview. So of course, if we were in person, we'd be able to lay out this map. It'd be fairly large. It'd probably cover most of the desk, and you could get a kind of a good vision of what it looks like. Unfortunately, here I have to scroll a little bit in my PDF viewer, but you could see that to the left here is the geologic map itself. The colors here are representing the different rock units, and so it's easy to see, when you look at the map, that there's certain colors that dominate, and you can kind of get a general overview maybe of the geology. There's always, of course, a key or a legend, and that's kind of here where it says description of map units. And they're organized in a specific way. Almost all geologic maps are ordered so that the youngest units are here at the top, and they get older as you move down the legend or explanation, and you find the oldest rock unit here at the bottom. Now, that's not always possible, but whenever it can be done, it is done in this fashion. So it's nice to be able to, once again, as an overview, if you need to find the oldest rocks on the map, you look toward the bottom and find the lowest unit, the youngest rocks at the top. Of course, it does have a title, some general information about the geology of the area. It also has a map scale here. So we have a ratio scale here. The scale of the map is here. Because this is mapped over a topographic map, it also has the contour interval. It has some other information like symbols, so there's some faults here and some other geologic information that can be added to the map. There's even a cross section. Once again, not all maps have cross sections, but this is along a specific spot of the map, so it gives you a profile of the geology, what's happening at depth. So I'm going to zoom in just a little bit here. So I'm just going to use my plus symbol here so we can start to read some of this information. And so as we zoom in, you can see now that the colors also have some symbols within the maps. And so this blue here is also referred to with this capital M and an R. The purple has a DM. This green looks like a PS, and of course, if you still can't see those, we can zoom in even farther. You can also see the topographic map below here. So when a geologist goes out into the field to create a geologic map, they're using a topographic map as their base. Because they know how to read that, they can locate themselves on the map. They use the features and elevations to figure out where they are, so longitude, latitude. And then they hike around the area looking what rock units are exposed under their feet as they walk along. And so, of course, if we were here, we'd have this MR unit, and as we walked in a certain direction, the rock units beneath our feet would change into something different. Like up here, it would go to another unit. And so where those two rock units touch is called a contact, and that's just drawn with this solid dark line. In places where it's a little unsure, it can be dashed. It's still a contact. And so other information we can get from this is the symbol itself is telling us something. All of the capital letters are referring to the geologic age of the units. So if we come over here to our explanation of units, you can see that all of these symbols here have a capital Q, which stands for quaternary. And as we scroll down here through the units, you can see all of these also have a Q. But if we look for our older rock units, the ones that were the blues and the greens, the M here represents Mississippian, the P, Permian. These are geologic ages. So we have a geologic time scale. Now that's available to you in the lab so you can look at it. It's a way that we group different rocks, and so if I bring this in really quick, this is a very simplified version of the geologic time scale, and the capital letters that are used on all of the explanation of units or the legend are associated with these particular names, these geologic time periods. And so we could see that if I move this out of the way really fast, the MR, the capital M, refers to Mississippian, and so that's why they're using an M. Now, for the most part, it kind of matches up, but not always, right? So Cretaceous uses a K. When they get really old, we're using some other letters here. So we wouldn't expect you to memorize this, so you would have access to this document/image, and you would, if I asked you, what's the geologic age of a rock unit, all you would do is look over here on the map, find the capital letter, match it up over here, and you would know the geologic age. There is a number associated with that, and that is the age range that's given here. And so the Mississippian has an age range, the Permian has an age range. Occasionally, in the descriptions themselves, they might have a more accurate age that falls within that span there, but not always. And so questions that we ask about geologic maps are, what's the oldest, what's the youngest, what type of rocks are exposed here? So the rock name for this blue, this MR, is called the Redwall limestone. That's the rock name. The MR is the rock unit symbol. The M, of course, is telling us the geologic age, which is Mississippian. And we would have to refer to our geologic time scale to find out what's the numeric age range there. And then it does give a description, of the rock units. Let me scoot over here. And so in some cases you can see it's fairly short. In other cases it is more extensive. So you can learn a little bit more about the types of rocks that are there. Let's see, what else? And so here's other symbols that are on the map that give us some information about the geology. We'll learn some more about these symbols in the future. For now, you can see there are some faults that exist here. The contacts are given here where they're accurate or approximate. And so we can look through stuff. And I did tell you that here's a cross section, right? A side view that you would see, right, from the map. We also said it tells us a location where it is in the state of Arizona. We see our scale and our interval here. There's the magnetic declination, just because magnetic north and geographic north aren't the same, so there has to be some adjustments there. Longitude, latitudes are here from our topo map, which we learned last week. And let's see. And that's the basics, I think, of our geologic maps. We can zoom back out so you can see the whole kind of story here. So most geologic maps are set up this way. So they'll have a legend or an explanation of units. They'll always have the symbols with the capital letter and the lowercase letter, where the capital letter is referring to the geologic age. They use the colors to differentiate. But you can see where there's a ton of yellows here. And how do you know which yellow is which? Well, you match up the symbols, and that's how you know what the age is or what unit it's referring to on here. In some cases, the ages get a little overlap here, and that's what this is, but we really don't get too much into that. So that's kind of the basics. Hopefully you can read through some other information that's kind of written out, some imagery that's in the lab itself to help explain more of this. But when you do the lab activity, it's going to ask you to download this map here, and then you'll be asked some questions about it. So you're going to kind of zoom around just like I did. You're going to locate some places on the map. You're going to identify certain features, ages, things like that. So that's what we kind of would expect from you for using this geologic map. And I'll make another little video for the lab itself so that you can work your way through this and, of course, our favorite Google Earth. Okay, so hopefully that's helpful, and I'll talk to you soon.